In this lesson, we will graph a parabola with a vertex of Hk. So again, very similar table to what we've seen on all of our other lessons this week. This gives us an idea of when to add, subtract, etc. So let's take a look at one together. Again, I'm graphing. I need to first find the vertex, and the vertex is Hk. H is always the value that's added or subtracted from the x value. So x minus -2 would be the x plus 2. Y minus 5, so it's positive 5. So -2 comma 5 is my vertex. 8 is my 4p. So 4p equals 8, which means p is 2. Now before, my focus would just be using x equals 2. But now I have to take my -2 plus 2 comma 5. So my focus is going to be 0 comma 5. So 0 comma 5 right here is my focus. The directrix, which before would have just been x equals -2, is now x equals the existing x value plus -2, so that's x equals -4. So that is my directrix. My axis of symmetry will go through the vertex, and again my axis of symmetry will be a y equals equation, so my axis is just y equals 5, so it's whatever the value is. So y equals 5. The focal diameter is absolute value of 8, which of course means 8, which means I'm going to go 4 in each direction from the focus. The focus was that point here, so I'm going to go 4 up and 4 down. Again, I can just look at the graph and then find the endpoints of the lattice rectum, which is 0, 9, and 0, 1. But if I didn't want to do it that way, I of course, I'm sorry, it's 0. I would take the focus, 0, 5, and then I would add or subtract half of the diameter to the y value, which would of course give me my 0, 1 if I subtracted, and 0, 9 if I added. To graph, I'm just going to go from the vertex, hopefully actually hit that point, and that will be the graph of my parabola. Here's one for you to try on your own. So try this question, then press play to check your work. Again, the first thing I'm going to look for is the vertex, and the vertex is Hk, and in this case that would be 2, 4. So x minus 2 gives me the 2, y minus 4 gives me the 4, so 2, 4 is my vertex. The focus would be found using my -8, so 4p equals -8, so p is -2, which means to find the focus, I'm going to use the -2 on the y value, so the opposite of this one, so on the y value, so I've got 2, 4 plus -2, which means 2, 2. 2, 2, that's my focus. The directrix would go in the opposite direction, so it would be a y equals equation, and I would take 4 plus +2, which of course would be 6. So y equals 6, which is right here. That would be my directrix. The axis of symmetry would be the opposite direction, so not a y equals but an x equals, and it's whatever the x value is of the vertex, which is 2. The focal diameter would be the absolute value of -8, which is +8, which means I'm going to go 4 in each direction from the focus. So from the focus, I'm going to use my 2, 2, and I'm going to add and subtract half of 8, which is 4, from the x value. So 2 minus 2, or 2 minus 4, which is negative 2, 2, and then 2 plus 4, which is 6, comma 2. So negative 2, 2, and 6, comma, no, hold on, 2, 3, 4, 5, 6, comma 2. And then, of course, I would just connect the dots. Connect the dots. I've got the vertex. I've got the focus. I've got the focal diameter. I've got the endpoints of the lattice rectum, which are right here, and the equations for the directrix and the axis of symmetry.